Okay, proportional segments theorem. We need to use that to find the value of x. We'll do this first one up here actually, because this one's a little simpler. It's so much like what we've been doing with everything else. So it's this length divided by this length is equal to this length divided by this length. So we can write it just like that. 20 divided by 10 equals 28 divided by x. Now just looking at this, I feel like I know the answer. Since this length is half of this length, we know that this length must be half of this length. So 28 divided by what equals 2 is one way to think of it. But we can cross multiply. Okay, divide both sides by 20. We get x is equal to 280 divided by 20. If you simplify that, you should get x equals 14. Okay. Now let's look at one that's a little more complex. Okay. Again, same thing. If we take this value and divide it by this one, should be equal to this value divided by this one. And that's because all of these lines that break these two transversals are parallel. Okay, so this value right here, you should know how to get that. It's that whole length of 35 subtracting 15. So that should be 20. 20 divided by 15 is equal to 4x plus 8 divided by 21. Now I actually can reduce this. I think I should because it'll make it easier. If you divide the top and bottom by 5, you get 20 divided by 5 is 4, and 15 divided by 5 is 3. So let's replace that with this. Make our lives easier, right? Okay. Ooh, I know an even easier way to do this. I know that if I multiply this by 7/7, I'll end up with the same denominator, 21, and 7 times 4 is 28. So I know that 4x plus 8 must equal 28. That's pretty easy. See, I could just take that out. We know that that'll have to be true since we have both the same denominator. So here's the quick trick. 28 equals 4x plus 8. Subtract 8 from both sides. We get 4x equals 20. So if you divide both sides by 4, you get x equals 5. Nice. That's a good little trick. If we didn't do that, we would have had to do this. 3 times 4x plus 8 is equal to 21 times 4. We'd have to calculate that. That's 84 is equal to 12x plus, what is 3 times 8? 24. Okay, subtract 24 from both sides, you get 12x equals 60. Cool, x equals 5. See how it works either way? Just have to check your numbers. Okay, this one. Triangle mid-segment. What do we know about the mid-segment? We know that it breaks this big line right here, LN, in half. to make wx. That's one way of thinking of it. So if we know that wx is equal to 1/2 the length of ln, we multiply both sides by 2. So 2 times wx is equal to 2 times 1/2 is 1, so we can just keep it at ln. And we know that wx is 13. We have the value for ln, which is 26. If you write that there, you should be able to see it. This is twice the quantity of 13. More simple way of thinking of it is, okay, this line is half the length of this line. So what's half of 20? Booyah, you're done. The reason why we can do this is because we know that the distance between here and here is the same as the distance between here and here, given these marks. We know the distance here to here is the same as from here to here, given these marks. Use the triangle midsegment theorem to find the value of x. Okay, these are a little bit harder, but we have the same idea of this is twice the length of this. Right, so x plus 15 is equal to twice the length. I'm writing 2 times 2x minus 12. This is how you should be solving this. So x plus 15 is equal to, let's distribute 4x minus 24. Could add 24 to both sides. We end up with, what is that, 39? 39x plus 39 is equal to 4x. And then let's just subtract 1x from both sides, and we end up with 3x. I think you know the value of x from here. Okay, for this one, same idea. Since we know that gi is equal to twice the length of yx, and we know that gi is 2x plus 20, and we know that yx is 2x plus 18, you can solve from here. Determine whether JK is a midsegment of AB. So this one you guys should understand from what we've learned. We know that if these two lines are parallel and this is half the length of this, then we know that JK is a midsegment. But can you tell? Is this half the length of this? No, it's not. So just alone in that, you should be able to tell that it's not a midsegment. We don't have to discuss whether the length from J to A is equal to C to A, because we already know this is not half the length of this. And it doesn't say these are parallel.